In this tutorial, we will see how to correctly position the photovoltaic modules on a flat roof. After having built the flat roof building, we need to click on the prototypes icon. Here, we can find our combinations of module plus structure already realized. We select the 10-degree ballast prototype, already made previously. This prototype was made to be suitable for installation on the flat roof. This is also confirmed by the system, which warns us that the prototype is suitable for flat roofs, highlighting the line of coverage in black. We now have two ways to position the modules: manual or automatic. Let's start with the manual mode. Let's go back to the 2D environment, in order to facilitate the positioning. Before dragging and positioning the panels inside the scene, it is a good practice to click on the Select button and indicate the side towards which we want the modules to be turned. In this way, the system will always align the modules to the side we want. In this case, we have an azimuth of 7.2 degrees. Once we have selected the side, we can click and drag our prototype into the scene and place it where we think it is most correct. Once the first panel has been placed, the system asks us to define a new field, that is the new surface, on which we have positioned our modules. We will have to create a new field every time we place panels, which have a different azimuth or a different tilt. In addition, it is necessary to define the operating temperatures, according to the NOC or Sandia standards. Or, again, in a custom way. We will use the NOC. Now let's assign a name to this field. We will call it Flat Roof. We can now save. At this point, by selecting the panel we have positioned, we see all the options that we can apply to it. We can rotate it, we can move it, but we can also use the command of stretch. With this function, we have the possibility to extend or reduce the rows, increasing or decreasing the number of modules. Here, we place a row consisting of 9 panels. To fill up the coverage, you will obviously need more rows of forms. To create them, we can use the duplicate command. We then drag the first row along the vertical axis, in order to stay aligned. Let's place it at an adequate distance, in order to prevent the modules from creating shadows between them. In any case, it will always be possible to go to correct the arrangement of the panels. We can also enter the number of times that we want to duplicate the row. We're going to duplicate it 5 times. We can see that the last row of panels clearly intercepts some obstacles. It will therefore be necessary to reduce the row. We select it, enable stretch, and we go to shorten the row by removing the excess modules. At any stage of the design, it is possible to select the rows of panels and move them in order to optimize the spaces. If we need to respect the safety distances, we also have the possibility to select the row and go to activate the quote button. At this point, it will be possible to go and define the distances between the panels and the parapets. Once we have positioned the module rows correctly, we can see if they are subject to shading. It will be sufficient to go to the analysis environment and click on the panel surface analysis icon. Select the field that we have created and click on Simulate Shading. From the calculation made, we can see that almost all panels have a productivity equal to 100%, which means that no modules are subject to shading. Once we have defined the distance between the rows of modules that we have placed, we can go to use the stretch command again. Let's go to extend the rows, trying to optimize the spaces. In this case, we select the row and duplicate it. Then we click on the duplicated row, and we go to reduce it, to adapt it to the available space. Once we have arranged our panels on the roof, we can go and repeat the analysis of the shading on the modules again, to see if corrections are necessary. We see that the only slightly shaded modules are those close to the parapets, and to the highest obstacles. These, however, have a very high percentage of irradiance. The analysis generated is performed at the cell level. If we wanted to analyze the impact of the shading at the diode level, it will be sufficient to change the type of analysis. Here at this point, the system will propose an analysis made on the entire diode, and no longer on the individual cells. We clearly see that there are some modules that have slightly more consistent losses than the others. At this point, we can decide whether to leave the panels in this position, perhaps by integrating a system of optimizers, or to eliminate the panels that are most subject to shading. We opt for this choice, and we are going to remove the panels that are not sufficiently productive. Let's repeat, once again, the analysis of the shadings. This time, we find a single, slightly shaded panel, being very close to an obstacle. To solve the problem, it will be sufficient to select the modules, and move them slightly. By moving them by a few centimeters, we have already solved a large part of the problem. Let's go now to create a new layer. By opening a new layer, it will replicate everything we have built: buildings, obstacles, plants, materials, and so on. However, the modules positioned on the coverage will not be replicated. These will, of course, remain saved in the previous level. We name the new layer, and give the OK. This is where we find our first configuration, and here we have a new workspace. In this new layer, we are going to see the automatic positioning mode of the modules. Let's go back to our prototypes, again the prototype for flat roofs, and select the fitting function. We are going to select the surface on which we want to place the modules. At this point, we have a series of parameters that we can manage: the horizontal distance, the number of modules per row, the distance between the rows. The one calculated by the system is the optimal distance, that is the minimum distance to prevent a row from being shaded by the front row, or from the rear row. At this point, we are going to select the side to which we want to align the modules. We see that the system creates a preview of how the modules will be positioned. If we are satisfied, click on Place. The system asks again for the name of the field, and the temperatures. We rename, and save the field. Here all the panels have been positioned automatically. Corrections may clearly be required. For example, these rows are very close to the front parapet, and therefore will have to be eliminated, as they would be completely shaded. When there are many obstacles, it is often preferred to use the manual mode, because it can be more precise, and the positioning of the modules can be better optimized. If, on the other hand, we have obstacle-free surfaces, the automatic mode is more convenient, as it allows you to save a lot of time. If we want to use the fitting mode anyway, but going to define the distances to be respected, such as from the parapets or obstacles, let's go back to the prototypes, and select the second box, the field, and click on our surface. At this point we apply an offset. This offset is applied starting from the parapets. If, for example, we wanted to leave a distance of 1 meter between the modules and the parapets, we write 1, and click on Apply. At this point, the system shows us the area within which the panels will be positioned. So let's go back to the prototypes. Select the fitting mode. Click on the area in which we want to place them, and the side to which we want to align the modules. Here is a new preview, from which we see that the required distances have been respected. We confirm the arrangement by clicking on Place. We define the new field again. And here we can observe how all the modules have been correctly positioned.